Welcome, good people, to 1.1 Lines in a Plane. This will be focusing on page 2, but since we're just getting started at the beginning of this year, just want to make a comment. You should be done with page 1. We've got some notes. We may come back and refer to that as we continue on, but everything that I have here on the notes and everything that I had back on 1.1 on the evens should be shown. I want to make certain that we are going through the videos. Even if you know what you're doing, you can get this assignment and just wrap it up without copying my videos. I'm really trying to throw some points in there and focus on understanding math this year and not just memorizing a process and finding our way through it. And that will be a challenge for some, but some it'll be immediately liberating. But trust me on that. I'll tell you the story about that when I have the opportunity. Everybody will end up failing at math if they're process-oriented at some point. It may not happen till college. That is if you continue your mathematics, but you cannot get by just by memorizing process in the long run. So with that, let's go ahead and jump right into these evens, which I'll go through. 35 through 42, determine the slope and y-intercept. Well, slope and y-intercept makes me think y equals mx plus b, because there's our slope and there's our y-intercept. So another way to think of slope and intercept form, if we come back here, would just be to think of this as, hey, it's just like this, except algebraically I need to solve for y. So you want slope-intercept form and you got an equation, you just solve it for y. So here we go. I'm going to get 4y equals, I'm going to subtract 3x, and I want to put it first. And subtract 3x joins the positive 1. So I've just minus 3x both sides. You do not have to show that work, but you can just jump right to here. In the next step, I need to divide both sides by 4, the entire side. So this would become y equals all of this on 4, or each term on 4. So determine the slope and y-intercept, then describe its graph. Wow. So our slope is negative 3/4. It's this puzzle piece. Our y-intercept b is 1/4. And wow, that's a pretty good algebraic description of the graph right there. I am satisfied with that at that point. And again, your goal is to do over here what I've done over there. So we're not always going to do exactly what's being asked of us. Because if I was going to describe this, I'd say, well, this is a line that goes through the y-intercept negative 3/4 and has slope 1/4. But really, we have it there. So I am okay without this, but I'm not okay with just that. That's really our final solution. Okay, so going to liberate you on multiple steps on algebra. We're going to get done with this a lot quicker this way. I'm going to get the minus 3y alone. I want to subtract 4x on both sides. I want to add 9 to both sides. And I call that rescuing. It's kind of like, hey, for starters, this minus 3y is my axe-wielding maniac. I've got to get rid of the 4x. How do I undo? This is a plus 4x. I subtract it. This is a minus 9. I add it. And now I need to get rid of the negative 3. So this is y is negative 3 is attached with multiplication. So I need to divide. Negative 4 on negative 3x plus 9 on negative 3. Or y equals 4/3 x. Plus minus, whoops, didn't really mean to zoom in like that. Plus divided by a minus is a minus. 9 divided by 3. Our slope is 4/3. Our y-intercept is negative 3. Okay, now just like back on problems 30 and 32, when you get these special cases undefined or 0 for slopes, highly recommend that you go ahead and just get a quick sketch of that. When it says y equals 12, I mentioned this on 1-1. The most common mistake made in this section is these plain old y equals or plain old x equals. Think of y as up down. So if up down is always 12, all the points on the graph are up 12. We're not over here 12 going up and down. All of the points on the graph are up 12, up 12, up 12, up 12, up 12, up 12. Oh, it's up here. So if that's up 12, then our slope is 0, and our y-intercept must be up 12. Okay? But yes, you get those special cases, like 39 is a special case. I hope you would treat that the same way. Try to think through that. As you may guess, that maybe there isn't always a y-intercept on a graph. Okay, and 42 will help us with that in that regard. Solving this for x, watch this, one step, x. X is paying most attention to 2, so I'm going to rescue 5 with addition. And then once 5 is rescued with addition, I can rescue 2 with division. Now I've got a special case. X is right, left. All of the points are right. 5 halves. All of the points are right. 5 halves. So the slope is undefined. And the y-intercept b, there will not be a y-intercept. We've got a vertical line there. So can't reiterate that enough. You get y equals or x equals, sketch it until you're really comfortable with it. Don't think x equals, think we're always to the right 5 halves. Don't think of this as y equals, think all the points are up 12. All the points over here on number 39 are left 6. All right, here we go. Find the slope and intercept form of the equation of the line. Find the slope-intercept form of the equation of the line. We have 2 points, and it sure looks like the y-intercept is 1 here, but can we be absolutely positive of that? So I'm going to go ahead and say our slope is y 3 halves minus, that's change of, -1 minus -1 plus 1, but I'm going to call that 2 halves on x, -1 minus, that's when things change, we subtract. Like if I'm standing on 7 and I go to 10, I've changed 3. We subtracted those. Minus 4, let's see, we get 5 halves on -5, that's on -5 on 1, so our slope is 5 halves times, flip it, 1 on -5. 5's cancel, but the negative doesn't. -1/2. Now, what's the intercept if I'm going down 1 over 2? I'd go from here, down 1 over 2, I'd be right here, but I could also go down 1/2 over 1. Down 1/2 over 1, our intercept is right here at 0, 1. So the y-intercept is, in fact, 1. There are other ways of doing that. We can get the equation of the line. All right. Write an equation of a line that passes through the points. Use the slope-intercept form if possible. Why might it not be possible? Well, I can't use slope-intercept form on this problem right here. We don't even have a slope. So you might have an impossible one in a homework set here. Use slope-intercept form if possible. If not possible, explain why, and use the general form. Use a graphing calculator to graph and check the line. We'll go ahead and just sketch the line, because once we've got it in slope-intercept form, we can graph it quicker than we can graph it with our calculator. So 2 points. I need a slope. Y's go from 3 to -4, they change, so that's minus, negative, plus. as x's go from 4 to negative 4. So our slope is 7/8. Our equation, I can use either point I want and this slope. Y minus a y coordinate, I'm going to use this one right here. Y minus a y coordinate becomes y plus 4 equals 7/8 times x minus an x coordinate. It's negative 4, so that's plus 4. So there's point slope form. To get that to slope intercept, we just solve for y. Slope, solve for y. So I get y equals, watch this, I think you'll like it, 7/8 x plus 4 reduces 8 to 2, 7 halves. What about this 4? I need to subtract 4, but minus 4 is minus 8 halves. Subtract 4 both sides. Y equals 7/8 x minus 1/2. Can I graph that? Sure I can. I'm at negative 1/2 and I'm going up and I'm going to the right a long ways. So let's see. There's my y-intercept. I need to be able to move up 7 from there. So let's see. Here's 1, 2, 3, 4, 5, 6, 7. But up 7 from here would be up 1, 2, 3, 4, 5, 6, right in there. And then I'd be over 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So a little bit crowded in there. May rework this out, but so write appropriately small as necessary. Let's go ahead. Slope equals y's go from 1. They change from 1 to negative 2/3. That's 1 minus a negative, 1 plus 2/3 on 1 minus 6. I get, that's 3/3 plus 2/3. 3/3 plus 2/3, 5/3 on negative 5. You can go to calculator with that if you want, but if I put that as negative 5 on 1, that becomes 5/3 times 1 on negative 5. 5's cancel, negative don't. We get a slope of negative 1/3. So we have y minus a y coordinate, I'm going to use the first one, equals negative 1/3 times x minus an x coordinate. And that gives me y equals negative 1/3 minus times minus plus, oh, there's an x here, minus times minus, that's plus 1/3 times 1, plus 1/3, and I need to add 1 to both sides. That's plus 3/3. So that's y equals negative 1/3 x plus 4/3. So my y-intercept is up 4/3, and I'm going down as I go to the right. So we're up 4/3, about right here. I'm going down 1 step, over 1, 2, 3 steps. Down 1 from here would be about right there. Over 3. Check it on your graphing calculator if you like, but I'm not going to require that. Okay, 60. I'm going to start and use a little bit of space over here. Y 0.6 minus negative 2.4 plus 2.4 over the x is changed from negative 8 to 2. So that is conveniently 0.6 plus 0.2 or 2.4 is 3 on negative 10. Well, that ended up a little bit nicer than I thought it might. So 3 on negative 10. So our equation is, don't have a real preference here. I'm going to use this point. Y minus negative 2.4 excuse me, it's not on. Y minus negative 2.4 equals negative 3/10 slope times x minus 2. Here we go. Y equals 2. Trying to think ahead. Y equals negative 3/10 x plus 2 reduces 10 to 5. The negatives cancel. I get 3/5 minus 2.4. And you can go to calculator on this, but I recognize this as 0.6. So we get y equals, maybe I'll just put everything in decimals since they started in decimals. Negative 0.3x. I have 0.6 minus 2.4 minus 1.8. So let's see. Our y-intercept, negative 1.8, negative 3/10. I'm going to go down 3 from there. Down 3 from there, about right here. As I go to the right, 10 from there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'd be looking like this. So there you have it. One-page math. Again, go on to the videos if you feel like you should, but my feeling strongly would be I would go back and just work on 35 through 59 and then proceed to the next page. We're just going to try to waka waka waka. If you watched video 1, you know what I'm referring to. Just one little bite at a time. Good way to learn math is like in 15-minute chunks. Let me know if I can help.